Hello guys, this is Wits Lounge, Learning Made Easy, and in today's video we're going to be understanding the concept of empirical formulas and molecular formulas. Don't forget to like and subscribe. Let's get into it. Now, I would like to start the study by describing the term a chemical formula. A chemical formula is simply a representation of a particular substance. It is basically those alphabets or things that are used to represent a particular chemical substance. Now, there are three major types of chemical formulas. You could have the empirical formula, the molecular formula, and the structural formula. However, in this video, we are going to be concentrating on the empirical formula and the molecular formula. So, what is an empirical formula? An empirical formula is the simplest chemical formula of a substance which indicates the proportion of combining elements in that substance. It does not give the actual number, it simply describes the proportion. Now, there are four basic rules that when you apply, you would be able to solve most empirical formula questions. Let's get into them. The first rule is this: identify the constituent elements in the compound. That's the first rule. Then we go to rule 2. Rule 2 simply states that we should identify the mass or percentage composition of the constituent elements in the compound. So we go to the third rule, which is divide the mass or percentage compositions of the individual elements by corresponding relative atomic masses. Please don't mix this up. When I say divide, you are dividing by the relative atomic masses. So if you have a percentage composition of carbon as 20%, you divide it by 12 because the atomic mass of carbon is 12. And that's that for the third rule. Then finally, you divide all the values from step 3 by the smallest value among them. So when you finish dividing by the atomic masses, you're going to have values. Then you check for those values and find the smallest one amongst them. Use the smallest value amongst them to divide every of the other values, and then you get your final answer. That final answer is what is used to represent the empirical formula. Okay, now there are two things I'd like us to note. The first thing I'd like you to notice: if you have a 0.5 decimal as a final value, if you have a 0.5 decimal, what I mean by a 0.5 decimal is 0.5, 1.5, 2.5, anything 0.5. Once you have a 0.5 decimal as your final value, multiply all the values by 2. Yes, once you have 0.5, don't approximate. You multiply all the values by 2. On the other hand, if you have a 0.3 or 0.6 decimal, you multiply all the values by 3. So have that in mind. With these simple rules, you can be able to solve any empirical formula question. Okay, let's try out some questions. We'll start with the first one. The first question we're going to try out is: an organic compound containing 40.1% carbon and 6.6% hydrogen has the empirical formula of dash. So let's solve this. The first rule is to identify the individual elements in this compound. As an organic compound, we should know that it should contain carbon and hydrogen. However, when you look at the options, you will now notice that there is also oxygen. So we'll have that the three elements involved here are carbon, hydrogen, and oxygen. Now, the next rule is to identify their percentage or mass compositions. Carbon has the percentage according to the question of 40.1. Hydrogen has a percentage of 6.6, but we don't have any information about the percentage of oxygen. However, we know that the total percentage is 100, which means that if we add carbon's percentage 40.1 plus that of hydrogen and that of oxygen, what we should get is 100. So applying algebra here, we are going to have that the percentage of oxygen will be gotten by minusing that of hydrogen and carbon from it, which is 46.7. And if we do that, x is going to be equals what do we have here? 53.3. So with that said, we go to the next rule, which is divide the individual percentage or mass compositions by the atomic masses. Now remember, in this question we're given percentage composition, so let's divide. We're going to divide this by the atomic mass, which is 12 here. The mass of hydrogen is 1. Okay, now here instead of x, we're going to replace that with 53. So remember that we've gotten x, and x is 53. So let's put it here, 53. So 0.3 I meant to say, but if we're dividing by 16 because that's the atomic mass. So we've done the first rule, which is identify the elements. We go to the second rule, which is identify their individual percentage composition. Then we divide through by the atomic masses. Now when you divide this, you're going to have 3.334. Now it's important to note that in chemistry, whenever you are solving a question that eventually yields or gives a decimal point, you are expected to write at least 3 decimal points when you are going to use that particular value to solve another. if you're going to still utilize that value, you are expected to approximate to at least 3 decimal points. Okay, so here is 6.6. We could put 00, and then here we have 3.331. So we are done with the third rule, and then we go to the final rule. The final rule is check for the smallest value amongst them and utilize it to divide everybody. So the smallest value is this. If I use this is going to be 3.331, divide also by 3.331, divide also by 3.331. Now when I divide through with this, I'm going to get 1 here, 2 here, and 1, which implies that our empirical formula is going to be how many carbon? We have 1 carbon atom, we have 2 hydrogen atoms, and 1 oxygen atom, and that is the empirical formula of this compound. So if you look at the options, you will notice that that is option C, and that's that. Quite simple, right? Okay, so let's try more questions on empirical formula. This time around, we are going to try a question that has to do with mass composition. The next question we are going to try is a sample of a substance containing only carbon and hydrogen bonds in excess oxygen to yield 4.4 grams of carbon 4 oxide and 2.7 grams of water. The empirical formula of this substance is dash. Now this particular question is a little bit more technical, so we need to, before we apply the rules of empirical formula, we would need to look into the question and understand it. Now first of all is this, that anytime you are given a question or a reaction between a hydrocarbon contains only carbon and hydrogen. Anytime a hydrocarbon reacts with oxygen, the only products gotten are carbon 4 oxide and water. Now the first thing I would like to tell you is this, that the total carbon inside this particular hydrocarbon is going to be found in CO2. So if I'm looking for the mass of carbon of this particular substance as seen in the question, where I'll find it is with respect to CO2. Same thing applies to hydrogen. Every hydrogen atom found in the hydrocarbon is going to be found in water. So when I'm looking for hydrogen or the mass of hydrogen, I'm going to look for it by identifying the mass of hydrogen inside water. Okay, so let's get to solve. Now we are asked to find the empirical formula, but to find the empirical formula we need the mass composition or percentage composition. So let's get to find the mass composition. So to find the total mass of an element inside a compound is quite simple. It is simply expressed by this relation. So you have given mass of element all over given mass of compound equals mass of element in 1 mole of compound all over molar mass of compound. So let's get to work. We are looking for the given mass of carbon, and that is going to be x, let's call it x gram of carbon, divided by the given mass of the compound. The given mass of the compound according to our question is 4.4 gram, and this is going to be equals the total mass of carbon inside 1 mole. Now carbon has the atomic mass of 12, and because we have just 1 carbon atom, it's still going to be 12. So this is 12. How many carbon atoms are in CO2? Just 1. So 12 times 1 divided by the molar mass of the compound is going to be C plus O times 2, which if we solve is going to be 12 plus 16 times 2. Eventually what we are going to get is equals 44. So we find out that if we write this, we are going to have x gram of carbon divided by 4.4 gram will be equals 12 over 44. If we cross multiply, x is going to be equals 12 times 4.4 divided by 44, and eventually we are going to have that x is equals 1.2 grams of carbon. I hope this is understood. Yes, so you have that the total carbon atoms inside this hydrocarbon would be found in CO2 after combustion, while the total hydrogen will be found in water after combustion. So you have that. Remember this relation, don't forget. Given mass of element over given mass of compound equals mass of element in 1 mole of compound all over the molar mass of the compound. So let's find that of hydrogen. Let's take this all out, probably use a different color. So let's do that for hydrogen. Now remember the relation I said is given mass of element all over given mass of compound equals the mass of element in 1 mole of compound divided by molar mass of compound. So this is quite important. So let's get the given mass of hydrogen. Now the given mass of hydrogen was not expressed in the question, but we can find it. X gram of hydrogen is now going to be equals given mass of the compound in this question was 2.7 equals the mass of hydrogen. We have one hydrogen, sorry, in H2O you have 2 hydrogen atoms and the atomic mass of hydrogen is 1 into 2 places all over. The molar mass of the compound is H2O, which is gonna be 18 if you solve it. We have videos that have described this particular concept, so please look it up. It's documentary videos. Okay, so with that said, if we cross multiply, we'll find out that X gram is going to be equals 2.7 times 2 divided by 18. Now let's take this to the lowest term. I think if 3 goes into this, 3 into this is 0.9, 3 into this is 6. We have 1 here, 3 here, 1, and this is going to be 0.3. So the mass of hydrogen is going to be what? 0.3 grams. Okay, so we've noticed this, that we've actually gotten the mass compositions of carbon and hydrogen. So let's now apply the rules of empirical formula. So the first rule is carbon and hydrogen are the constant elements, only constant elements there as indicated by the question. The mass composition of carbon, as we found out, is 1.2 gram, while that of hydrogen is 0.3. Remember, you could divide the percentage compositions or mass composition. In this question, we are dealing with a mass composition, so we utilize it. Now, having gotten the mass composition, the next thing we need to do is divide each of these mass compositions by their corresponding atomic masses. So if you divide this by 12, you're going to get 0.1, and if you divide this, you're going to get 0.3. Now, after we've applied rule number 3, the next thing to do is to divide all the values by the smallest value amongst them, and that's 0.1. So if you divide by 0.1 and divide by 0.1, we're going to have 1 here and 3 here. So our empirical formula is now going to be CH3. Quite simple, right? And it's actually in the option. So you have that. Very easy to understand. Now, we're going to solve one last question for empirical formula before we get into the study of molecular formula. The next question we're going to solve is a hydrocarbon containing 88.9% carbon has the empirical formula of dash. A hydrocarbon containing 88.9% carbon has the empirical formula of dash. Very simple, so let's get to solve it. Now, if you notice, they mentioned hydrocarbon, which means only carbon and hydrogen. We go to the next step, which is identify their percentage composition. The percentage composition of carbon is 88.9. That of hydrogen was not given. Let's call it X. Remember, we said that 100 contains the 2%, which is 88.9 plus X. Using algebra, we are going to have that. This is going to be minus 88.9. Therefore, X is going to be like 11.1%. So, in place of X, we are going to be putting what here? 11.1. Quite simple, right? Good. So we go to the third rule, which is divide each of the constituents by their atomic masses. So if we divide this by 12, we're going to have like 7.408, and then here we're going to have 11.1. We're done with that. Okay, now after this, the next rule is to divide each of these values gotten from rule 3 by the smallest value. The smallest value is 7.4. 11.1 is bigger than 7.4, so we're dividing with 7.4. So if we divide by 7.408, divide by 7.408, when you divide this, you get 1. If you divide this, you get approximately 1.5. Now, we are not going to have our final answer as CH 1.5. If you noticed in the rules, this is not going to be correct. Why? Because earlier on in the rules, we said that when you have a 0.5 decimal, you simply multiply all the values in that particular empirical formula by 2. And we have a 0.5 value here, so we're going to multiply both 1 and 1.5 by 2. If you do that, you are going to have your final answer as 2 here, because 2 times 1 is 2 and 2 times 1.5 is 3. So what is going to be our final answer as the empirical formula is going to be C2H3. Remember that if this was a 0.3 value or 0.6, we're going to be multiplying by 3. I hope this video has been helpful to you. Now, we are going to be getting into the next type of chemical formula, which is molecular formula. Now, what is a molecular formula? A molecular formula is simply the simplest chemical formula of a substance, which indicates the actual number of elements inside one mole of the compound. So when you're looking at the molecular formula, it tells you the exact number. Now, every molecular formula is derived from the empirical formula by this relation represented. So whenever you want to derive a molecular formula from an empirical formula, you simply relate it by this. You write molecular formula is equals empirical formula multiplied by n. And the question is, what is n? To find n is quite simple. The n is given as the molecular mass divided by empirical mass. Now, in most cases, you would have that the molecular mass would be given. And what do I mean by the empirical mass? The empirical mass is the mass of the empirical formula. That is the mass of the elements combined in the empirical formula. Okay, so in some cases the molecular mass might not be given. So what do you do about that? Some cases you might be given the vapor density. So how do you find the molecular mass when you are given vapor density? You find out the molecular mass when you are given vapor density would be equals vapor density multiplied by 2. So anytime you look at a question and you are given the vapor density, molecular mass is equals vapor density times 2. Now, in some cases, the questions can be more tricky, and in those cases, you would be expected to relate mass, volume in cm cube, and molecular mass. So to find the molecular mass when you have mass and volume is quite simple. How do you get that? The molecular mass is going to be given as molecular mass is going to be equals mass times 2 to 400 divided by volume in cm cube. So these are like formulas that you could just put in head. They actually derive from stoichiometric relations, so please look up our videos on stoichiometry to find the different ways of finding the molecular mass. Having said this, we get into solving questions. Okay, the first question we are going to be looking at is quite simple. It simply states that an organic compound has the empirical formula CH2O and its vapor density is 45. What is the molecular formula? Very simple, right? Good. Now, the first thing we noted is that molecular formula is equals empirical formula multiplied by the value of n. And the first thing we need to find, which means that in this case, we're going to have that our molecular formula is equals, the empirical formula in this question is CH2O multiplied by n. So let's find n. N is equals the molecular mass divided by the empirical mass. In the question, we are not given the molecular mass. So let's find the molecular mass. The molecular mass is going to be equals vapor density multiplied by 2. So if you look at our question, you will notice that we are actually giving the vapor density instead of the molecular mass, and we can, it's no problem. You convert the vapor density to molecular mass by timesing by 2. So that's going to be, in this case, we had 45 as vapor density multiplied by 2. Therefore, the molecular mass is going to be 90. So you have that, you're going to have 90 divided by. Now let's find the empirical mass. Now, the empirical mass, as I said, is the mass of the constituent elements in the empirical formula. So let's find it. We have one carbon atom, and the mass of carbon atom is 12 plus 2 hydrogens. So plus hydrogen's atomic mass is 1 times 2, then plus finally oxygen, which is 16. So if we add up all these things, the empirical mass is going to be 12 plus 2 plus 16. Therefore, the empirical mass is going to be 30. So if you have that, we'll have 90 divided by 30, and if you do that, you're going to have that 90 over 30 is going to give you 3. So our n value is 3. So we are not done solving. Let's take this out and continue. Now, given that the molecular formula is equals CH2O multiplied by n, and our n is 3, what we simply do is that we're going to replace the n with 3. Therefore, the molecular formula is now going to be what? C multiplied by 3, which is C3. H2 multiplied by 3 is going to be 2 times 3, which is 6, and 1 times 3, that's for oxygen, would be 3. And that's our answer. Quite easy, right? Good. I hope this video has actually been helpful to help you understand how to resolve questions with respect to molecular formula. Remember, this is Wits Lounge, learning made easy.